We're working on an oxidation-reduction reaction. We're going to balance it using the half reaction method. And I've already written some things down so I can see if I can get this problem done in less than 15 minutes. So I chose this species for the oxidation half reaction because the oxidation number went from +3 to +5. Remember, oxidation is loss of electrons, loss of negative charges. So I've written here the species in which oxidation occurred, and then just below that we've written the species in which reduction occurred, where the oxidation state went from a +5 for nitrogen to a +2 for nitrogen. Gain of electrons is reduction, and the oxidation state is reduced or lowered. So I've written the species here that were involved in the reduction reaction, the reduction part of the reaction. Now we're going to balance this. It says for each of these half reactions, balance all the elements except hydrogen and oxygen. So here, to balance the AS, we're going to put a 2 here. Gives us 2 AS on both sides. Now to balance the oxygen, we are going to add water to both sides. Why can I just add water? Because this is happening in an aqueous solution. And so here we see 8 water, 4 times 2. So to get 8 waters here, we have to add another 5. To get 8 oxygen, we have to add another 5 water. Now to balance the hydrogen, we add hydrogen ions. So here we have, why can we just add hydrogen ions? Well, it's because we're in an acidic solution, and as acids produce hydrogen ions in solution, so we can just add some hydrogen ions here. Isn't that simple? So we've got 10 hydrogens here and 6 here, so I need to add 4 hydrogens to each side of this equation. So the hydrogens are balanced, the oxygens are balanced, everything else is balanced, except we now have to balance the charge. In other words, here in the reactant side, we have a charge of 0 in this particular example. And whatever that charge is, we have to make the same charge on this side. Well, right now, we have +4. How can we get the charge from +4 to 0? By adding 4 negative charges in the form of electrons. So now the charges on both sides add to 0. They don't have to add to 0, but they do have to add to the same thing. And the only thing we can do to adjust that charge is add electrons to one side or the other. Now let's go to the reduction half reaction and go through it in the same way. The nitrogens are balanced. We're going to balance the oxygens by adding water. So to get that, we need to add 2 water. That gives us 3 oxygens on each side of the equation. Now we have 4 hydrogens here. So to balance the hydrogens, we have to add 4 hydrogen ions to this side. So the hydrogens are balanced, the oxygens are balanced. Now we have to balance the charge by adding electrons. So over here we have a 0 charge, and over here currently we have 4 plus and 1 minus. And so to get the charges to both of them be 0, we need to add 3 more negative charges. So 3 negative charges plus 4 minus 1. We have the charges on both sides adding up to 0. They don't have to add to 0, but they do have to be the same on the reactant side and the product side. Now another thing that has to be exactly the same is the number of electrons that are gained in the reduction reaction have to be exactly the same as the number of electrons that are lost in the oxidation half reaction. And we see here that that is not the case. So we have to multiply. The next step tells us we have to multiply each of these half reactions by an integer, usually a small whole number integer, so that we equalize the number of electrons transferred. And so here I think you see that if we multiply this reaction by 3 and multiply this reaction by 4, that will give us 12 electrons. 4 times 3 is 12. And it will give us 12 electrons up here. 4 times 3 is 12. So that the number of electrons is equal in the two processes. Now the fourth step says to add these half reactions together. And I'm just going to draw a quick circle around here so you get an idea of what I'm talking about. We're going to add all of these reactants, and we're going to write that down below as reactants, and we're going to add all of these products together, and we're going to write them down below. And we've got to keep in mind that there are these coefficients, the 4 and the 3. So here's what we're going to do. Down here below, we're going to start by writing the 5 times 3. That's how many waters we have. 5 times 3. That's 15 H2O. We're going to add 3 AS2O3. 3 AS2O3. That's a 3. Good. We're going to add, here's our 3 times 4 electrons. That's our 12 electrons. We're going to add our 4 times 4 hydrogens, ions. So that's 16 hydrogen ions. And we have 4 nitrate ions. And that should be all of the reactants from both half reactions. Then we're going to make our arrow, and we're going to add up all the products. So the products we have here, we have 2 times 3, so that's 6 H3 ASO4, and we have 4 times 3 hydrogens, so that's 12 hydrogen ions. And we're moving, we have the 12 electrons, of course. Running out of room, I'm just going to start writing down below here in a moment. We have NO. We have 4 of those. 4NO. And we have 8 waters. 8 H2O. Now the very last, actually the next to the last step is they're still in step 4, cancel identical species. Well, one identical species, one thing that has to be identical, are the exact 12 electrons. If we don't have the same thing on both sides, we need to start over and figure out what we're doing. Anyhow, so we cancel out the 12 electrons on both sides. We have 15 water here and 8 water here. So we can cancel these 8 waters. So 15 minus 8 leaves us 7 water, 7 H2O. The AS2O3, none of those cancel. So we have 3 AS2O3. Let's look at the hydrogen. We have 16 hydrogen right here and 12 hydrogen here. So we're going to get rid of 12 of those hydrogen from both sides. That leaves us with 4 hydrogen ions. And we have 4 NO3 negative, 4 nitrates. That's all of our reactants. So we have 6H3ASO4, and we have 4NO. Now if you check these, the last step says to check and make sure we have all the elements, so that we have, for example, the same number of hydrogens here as over here, and the same number of AS. In other words, there's 6 of them here, so there needs to be 6 of them here. And if you check all of those, you will find they're balanced in this example. We also have to check the charges, and we have to make sure the total charge here, which is 0, is the same as the total charge here. Here we have 4 plus and 4 minus, so the charges add up to 0 on both sides. So the equation is now balanced. This is our balanced redox reaction for the reaction that we started with. Wasn't that fun?